population under the topic of preliminary in Dr. Zen Lu.
Good morning, everyone. First of all, let me say a word of thank you to the organizer for inviting me to give a talk today. And of course, a big congratulations to our Thai colleagues for putting together this meeting despite all the difficulties and challenges caused by COVID-19 pandemic, which we are all facing at the moment. Okay. So today I'm going to share with you some of the preliminary works that we did recently, where we compare the pharmacogenomics markers in the Malay population groups in Brunei and Malaysia. So first of all, I would tell you why we think that it is necessary to compare the two Malays population groups in the two countries, and then we're going to share with you some of our workflows, how we did the comparisons, and then perhaps a bit of our results and what we plan in the futures. Okay, so the first question we then ask ourselves is how similar or how dissimilar are the Malay population groups in the Southeast Asian regions. So what we did then, we took genotyping data from different from different public databases, and we also got some genotyping data from some of our colleagues here that was done recently on two of the Malay groups in Brunei. So as you can see in the principal component analysis and the admixture analysis here, the Malays in Brunei and the Malays in Malaysia and Singapore can actually be segregated into two different groups. So on one side here, you see the Malays in the Peninsular Malaysias, and also those in Singapore are closely related, whereas the Malays in Brunei are slightly more separated from the other Malay groups, and they sort of sit in between the indigenous Filipinos groups and the Malays in the Malaysia and Singapore. And of course up here you have the East Asians population groups and the Indians from the Indian subcontinent, and then the Europeans. So in fact, if you look at this admixtures plots here, you can see that it's very obvious that the Malays in Brunei actually contain more genetic materials from East Asia than those Malay in Malaysia and Singapore. Okay, so that gives us quite a lot of confidence that we might see also some differences in the pharmacogenomics markers in these two population groups, and perhaps we can use it as a potential more stratified pharmacogenomic approach for the two population groups. Okay, so what we then did was we compared the two population groups. So our Malaysians data came from the our colleagues in University Malaya and University Science Malaysia. This the sequencing data, the 100 pharmacogenes sequencing data done by the Rikens in Japan. And then for so there are 105 samples, of which 81 are Malays and 24 are Chinese. And then we compare them against the two Bruneians data, which were derived from whole genome sequencing. So we didn't. So for comparison, we actually took just the exon coding bits from this whole genome sequencing data. Okay, so and I want to quickly say something about the Malays in Brunei. So the Malay in Brunei is actually made out of 7 different ethnic groups, or 7 different, I suppose you can also call them tribes if that's the right word to use. The Malay status that we use in these studies were from ethnic group called Dusun. Okay, right. So just to share with you the workflows that we use. For the mappings, the variant calling and the annotations, the initial annotations, we use very much the recommended pipelines from GATK. Okay, so here are the software, the main software or tools that we use. So BWA was used to initially do the mappings of the NGS reads to the reference genomes, and then we do the GATK variant callings, and then from time to time we use the SAM tools to manipulate the BAM files if necessary, and then once we get the final VCF files, this will then fed into FunCat for the annotations of the pharmacogenes, and then ANOVA for the others, well, actually for all the genes as well. Now I want to actually say something about the human reference genomes that we use. Now I understand that our colleagues in Thailand actually use the earlier version of the human genome, HG19. We decided to use HG38 mainly because we think that there have been quite a lot of improvements in the in the human reference genomes in HG38, and the other thing is the interval files that we use to call our variants. So these are the exon coordinates that we got from the reference sequence, the reference coding sequence, the mRNA coding sequence. So based on the RefSeq, okay. And then for the recalibrations and annotations of the variants in GTKs, in addition to the resource bundles available from GATK, we also throw in the genotyping data, the genotyping variants from the Singapore Sequence Malay project and Singapore Genome Variation projects. Now we think that by including a more related population groups that is more related to to the Malays here, we might be able to improve the variant callings, the accuracy of the variant callings. So after obtaining the VCF file generated by GATK, we then fed into the FunCat programs. So this is an overview of the FunCat workflows that we followed. Actually, before we even start the FunCat pipelines, we did a few pre-processings. Now, the reason that we did that was because earlier on, if we fit the VCF file from GATK directly into the programs, we kept running into an errors, and the program just crashed without finishings. So I would in the next slide I would talk a bit more about these particular errors. The other things that we did also was to remove those that potentially mark as false positive variants by GATKs. Okay, perhaps and another point worth mentioning is that the FunCat programs. We have to remember that the FunCat program actually only annotates 14 out of the 100 pharmacogenes. Okay, and so the rest then we will have to rely very much on ANOVAs. Okay, right. So the errors. Okay, so the errors was actually caused by an index in our files, in our VCF files. So what you see here on top here is the entries from the GATK, the original entries. Obviously there is an insertions here, and the way that the way that GATK write the insertion is that it has this insertion as a GGA-GTC. Now there's nothing wrong with this GGA-GTC. So if you see that the insertion is really quite true, that it can be GGA-GTC, GGA-GTC, and GGA-GTC. So basically it's a tandem repeats of 3 units here. But on the other hand, you can also argue that the insertions can be written, or the tandem repeats can be written as GAG TCG, which is shown here. So you see the GAG TCG, GAG TCG, and then GAG TCG. Okay, so and so unless we change this and also the coordinates here, the program would not run smoothly. Now we reckon that this was probably due to the DB-SNPs the DB-SNP accession number associated with this particular insertions. There was if you look through the history of DB-SNPs, so this particular SNPs is actually this particular indel, sorry, is actually the result of merging a previously reported indels as well, and hence there's a slight change rate. So we believe then the so there might be a different way of looking at it, the GATK and the FunCat, when it's probably due to different version of the DB-SNPs that they use. Okay, anyway, so we managed to resolve that problem. Okay, so let's look at some of the results that we have then. Okay, so for the mappings, we found that for the Malaysian data anyway, we found that the average coverage is actually quite low, so it's below tenfold. Even the maximum average coverage that we've seen in all the data, there's only about 62 folds. And if you then look into the areas where their coverage is greater than 30x, it only covers less than well, about 1% of the total regions. Now we usually say is that to get a good qualities, you should ideally have about 30x fold. So because of this low coverage, so I guess we have to take some of the results with a bit more cautious. Okay, so and in fact, out of 105 samples, one of them actually didn't work. So if you look at some of the mappings here, okay, so we have seen some where the coverage are very low. Not only that, but also it only cover part of the axon, say in these pictures, as you can see. Or there are regions where there are totally no coverage at all, so the reads are completely missing. Or we also see areas where the coverage seems to be quite good across the entire axons, but you see a lot of variance, which we reckon that is most likely due to mapping errors or sequencing errors. We don't know. Okay. Okay, so next we then look at the all the variants that we have code from GAT case. So as you can see, the total number of variants that we found in the Malaysian data is 752 compared to 276 in our two Malays in Brunei. Now the lower numbers here are mainly because we only have two samples here compared to 104 samples here. Obviously, the more samples you have, then the higher the more variants that you will expect to find as well. So of this, we found some novel sequences, novel variants as well, and quite interestingly, I think, which we don't quite know how to explain this, or whether this is really the truth. From the annotations that we did, we found that actually in the Malaysian data set, a large number of the variants actually have minor allele frequency lower than 0.05, whereas ours in the two Dusun genomes that we found are far less, and we sort of expect this is probably the more likely result. But so we need to look into a bit more details what is happening here, and hopefully the next time when we meet again, we can report to you what exactly is happening here. Again, the other thing is the other reasons, I guess, is because our coverage, as you can see from the whole genome sequencing, is actually quite good. I don't know whether this low shallow coverage have anything to do with some of the potential errors that we are seeing here. Okay, and then we then let's then look at the FunCat result. Okay, so this is the pharmacogenes that we found to have been annotated by FunCat because they contain one allele or another which are responsible for drug responses. Okay, so excuse me. The total number of genes or pharmacogenes in the Brunei Malays, they have known pharmacogenomics implications. There are 3 of them, whereas there are 8 of them found in the Malaysian data, and you can see that here are some of the alleles which may be responsible for different level of drugs metabolisms. Either they can cause poor metabolisms or intermediate metabolism, or that you might have to adjust the dosage of this. Okay, in this slide, it's basically showing us the drugs that may be affected by the alleles that we saw in the 2 Malay population groups. So some of these drugs are probably quite commonly used as well, including warfarins. But I want to actually stress that this is very much a very preliminary look into the data. I think we still have some cleanings to do with the data, and we might be coming back with more reports of different consequences as well. Okay, right. And then looking at the ANOVA annotations, we found that actually some of the genes actually missing, or well, there are no variants was called from these genes. So as you can see here, those highlighted in yellows, the genes where there was no variant code at all for the Malaysians data, and those in red are those genes where we didn't find any variants in the Brunei and Malaysia. And there's one genes here, the GSTT1, where both the both Malay groups in Brunei and Malaysia have no identifiable pharmacogenetic variants. So that so what I've just shown you is very much a work in progress, because we are actually waiting for our own sequencing data. Now I know that I've been talking about this for a while, but I guess the COVID-19 pandemic has in one way or another has slowed down our work or delayed our work, our sequencing work, especially the initial part with the recruitment of volunteers. But anyway, so we are planning now to start sequencing very soon. In fact, if everything goes well, we will start our sequencing next week. At the moment, we have already recruited. We have actually collected more than 60, nearly 60 DNA samples, which we extracted from salivas. So hopefully, when we meet again next time, we are able to give a more complete comparisons of the Malay's pharmacogenomics markers, not only in Brunei, between Brunei and Malaysia, but hopefully among all the Malay Austronesian groups in Southeast Asia. So to end my talk, I would like to acknowledge some of the peoples that have been helping to make this work possible. So Abdul Musik, my students who did most of the work I presented here today. Mirza has been helping us with the GATK, and then my two others junior colleagues who recently joined or started the pharmacogenomics research as well. And then I have other collaborators from the universities and also the Ministry of Health in Brunei as well. And of course, the work has not been possible, or the comparison has not been possible without Dr. Samsu from University of Malaya and Dr. Zo from USM to agree to share the Malaysian data with me. And then of course I have to thank the CFUN consortiums and my universities for funding the works that I'm doing now. And to close this talk, so if any one of you is interested to do more of these comparative studies among the I would say the Austronesian groups, so there is people from data, so I think it might be interesting to actually compare data from Indonesia as well, and perhaps also from southern Philippines if they are available. Okay, so thank you very much then, and I look forward to answering some of your questions.
Thank you very much, Dr. Zelu. We have learned a lot from you. Thank you for your fruitful sharing. And it is impressive that we are getting even more and more full participation than ever for this session. That is why I'd like to start with our Q&A session right now at this very moment. So the first question for you is that what is the current state of knowledge and clinical implementation of pharmacogenomics in Brunei? That is the first question.
Okay, actually, if you don't mind, I would actually answer the second question as well, because I can see that in the Q&A. I think the two questions are actually related. So maybe I can just read the second questions as well. So the second question asks, are you conducting evaluation studies on the impact of pharmacogenomics application in a healthcare settings in Brunei? If not, what are the challenges? Okay, so Brunei is part of the WHO pharmacovigilance, is a member of the WHO pharmacovigilance. So we are required to report ADRs and information such as that to WHO. But unfortunately, due to limitations in manpowers, we are a bit behind with that. So the data are collected and very much in handwritten form. So we need to map them into electronics and get more information in terms of the status of the pharmacogenomics. Now, in terms of PGX testing, we don't run any PGX testing yet. We are very much at the beginning of our journey. So we are foreseeing ourselves to start this kind of services probably within the next 3 years, hopefully. So we are building our own human capacity in these areas as well. In terms of the evaluations of evaluation study, yes, we would like to do that, and in fact, we very much like to do that. I've been talking to colleagues in business departments and also colleagues in public health and of course our colleagues at the Ministry of Health as well. So but we don't really have a lot of expertise in health in terms of health economics. So I'm just thinking maybe we can get some help from our colleagues in Thailand as well, trying to help us to do this kind of studies. Okay.
Thank you much. We also have another question for you from Fukunaga Sang. Why did you use TATK best practice, including trimming low quality base and indel realignment?
Okay. We actually used other tools before as well, but we found that GATK give us much better results comparing to other tools. And in terms of the best practice, we did actually modify some of the parameters and to suit our need. We didn't really follow exactly what is recommended by the GATK teams. I am quite open to other suggestions if there's a better way of improving the alignments. Yeah. So, Dr. Fukunaga, you are more than welcome to get in touch and give us some advice. Yeah. Okay.
Thank you very much, Dr. Zelu. We've learned a lot from you. Thank you very much. And I believe